Hello everyone, we're looking at a combination of transformations today. We've focused in the past on translations, moving objects up, down, right, or left. We've looked at reflections, we've looked at rotations, we've looked at dilations. Now we're going to combine them in a series of steps. We normally do this in class with a group so that you can compare results here in our notes. I'm going to do an example here on the right hand side, and then you will do the work on the bottom below the graph following how I did the example. So there will be a little bit of a setup that I need to do here for this example because we're doing not just one but two transformations. There's going to be a lot of numbers, a lot of detail that we're working with. We have here a menu of options. You can see here we have a reflection, here we have a translation, here's a rotation. That CC again means counterclockwise. We always rotate counterclockwise, so you're really just talking about the fact that it's a 90-degree rotation. Here's a 270-degree rotation. Here's a reflection in the line. Here's a translation. So that's going to require you to be familiar with all of the notation and the rules that we've developed for rotations and reflections, and if we have vertical or horizontal lines. So you might have to flip back in your notes to look at those rules that we gave you or the methods we showed you to be able to do that. Here is a menu of 6 options. We're not doing 6 of these. We're just going to pick 2 from the menu, and that's just what we'll work with for today. Here's our pre-image. Here's our polygon. And for my example, I am selecting these 2. I'm going to say, okay, let's see what happens when I first do a translation and then a rotation. Okay, so what I need to do is first of all determine what those coordinate points are. So this will be a long list, and I'll just use this column to write them down. So I'll create a space for A, B, C, and so on. We've got 6 of these points. This is my pre-image, and so just reading the numbers off of my grid, A is at 3, 5. B is at 4, 5. C is at 4, 2. D is at 5, 2. E is at 5, 1. And F is at 3, 1. So our very first transformation in this example says, let's first translate. We're using pattern number 2. So we're going left 7 and up 2. So if I think about what that means, here's how we write the rule for a translation. If we're going left 7, we want to take the x-coordinate and subtract 7. Oops, I did not mean for that parenthesis to go there. I wanted a comma. Then we'll take the y-coordinate and add 2. Alright, so there's our close of the parenthesis. So to create A prime, B prime, C prime, D prime, E prime, and F prime, I need to follow that rule. So just setting up my table here. So I like to do one at a time. So let's take each x-coordinate and subtract 7. Alright, so that means 3 minus 7 is negative 4. 4 minus 7 is negative 3. For point C, 4 minus 7 also negative 3. For point D, 5 minus 7 is negative 2. And 5 minus 7 again is another negative 2 for point E. And then lastly, 3 minus 7 is negative 4. Now for the y-coordinates, we're going to go up 2. So we're adding 2 to the y value. So let's go down the column. Here we have a y-coordinate of 5. So 5 plus 2 is 7. 5 plus 2 is 7. 2 plus 2 is 4. 2 plus 2 is 4. 1 plus 2 is 3. And 1 plus 2 is 3. That's the result of the translation. So let's plot those points. So A prime is at negative 4, 7. There's A prime. B prime is at negative 3, 7. C C prime is at negative 3, 4. D prime is at negative 2, 4. E prime is at negative 2, 3. And F prime is at negative 4, 3. There it is, there's our image. But we're not stopping there. Now we're going to take that object, because it's not here anymore, it's moved. Now it's here, we're going to take that object and we're going to apply another transformation. We're going to rotate it with the option 3. So the rotation here of 90 degrees, we'd have to look back in our notes for those rules, and that rotation says we're going to take each coordinate point and change it in this way. We want to switch the numbers around, and then we want to change the sign in front. Okay? So that means we have yet another transformation. We're going to rotate, which means I'm going to take this column and just extend it downwards, because now we're applying another change to get a double prime. So the double prime means now that we've changed it twice. B double prime, C double prime, and so on. So again, just setting up the column here to prepare for the numbers. So with this rotation, we are going to take the x and y coordinate, we're going to switch them around, and then change the sign in front. Now we have two sets of points. Which ones are we using? We're not using the originals because the object isn't there anymore. It's been moved. These are the points representing where it is now. So these are the numbers. This is the object that we're going to be rotating 90 degrees around, the center of dilation, the center of rotation. And so here, these are the points we're going to use. So take that A prime, which is at negative 4, 7, switch the numbers around, and then we change the sign in front. So it looks like a negative 7, negative 4. Point B is negative 3, 7. So switch those numbers around, change the sign in front. Point C, switch those numbers around, change the sign in front. Point D, negative 2, 4, switch those around, change the sign in front. Point E prime, which is negative 2, 3, switch those numbers around, change the sign in front. Lastly, F prime is at negative 4, 3, we switch those around and change the sign in front. Let's plot those points. A double prime is at negative 7, negative 4. B double prime is at negative 7, negative 3. C double prime is at negative 4, negative 3. D double prime is at negative 4, negative 2. E double prime is at negative 3, negative 2. And lastly, F double prime is at negative 3, negative 4. So we could have picked any combination of these. We could have done a rotation followed by a rotation. We could have done a translation followed by a translation. We could have done a reflection followed by a reflection. It could be the same. Or it could be two different transformations. We could have done a reflection followed by a translation. You get the idea. But here's the big question we're looking at today. If you take these exact same two transformations, but you did them in the opposite order, would our pre-image still end up in the same location? And that's what I want you to try down here. Does the order of the transformations matter? So I want you to use the exact same two that we just did, but now switch them around, go in the opposite direction. So you're going to first start off by rotation with option 3. Then you'll take that result and you'll translate it using option 2. So it's the exact same rules. We're just switching the order around, and the big question is, does the order of the transformations matter? Will we end up in a different place, or will we end up in the same result, same location, which would indicate that the order does not matter? So think about that first. What do you think is going to happen? And then try it. So here we have in this space, write the coordinates of the original figure. That's what we did right here. So just copy those numbers down, and then you're going to apply the rule for the rotation, and then for a double prime, you'll apply the rule for the translation, and then see what you come up with. So pause the video, take some time to do that. I'm not going to give you the answer here. That's something I want you to figure out. And then when you're ready, turn it back on, and we'll turn the page and go on to the next example. Alright, moving on to the next example. Here's example 2. This time we're thinking in reverse. They have already provided us a series of changes that have now resulted in this triangle called A double prime, B double prime, C double prime. With the double prime, you know it's been changed twice. But how has it been changed? We want to specify the sequence of transformations that maps or connects triangle ABC to triangle A double prime, B double prime, C double prime. So it does help to have some tracing paper here so that we can kind of figure out how in the world it is moving. But we have to think about things like, is it reflecting, is it rotating, is it dilating, what could that be? Well, if I just take a look at how it's lying on the side, here the original pre-image, the longer leg is on the bottom, and after the change, the longer leg is on the height. So it looks to me like it's rotated. Now when we rotate, remember that we have to rotate about the origin. So I'm going to give this a 90-degree turn, and you can see that now our triangle is lined up the same way, where the biggest leg is on the height. That's good. If I were to rotate too far, here's a 180-degree rotation, that doesn't line up the triangle. Nope, that doesn't help. So what I'm thinking is we should probably do a 90-degree rotation first, and then we're going to shift this triangle a little bit to the left and a lot down so that it lines up like so. If we were to try and shift the triangle first and rotate second, I'm thinking like if we were to shift it this way and then we were to try and rotate it, it would be close, but it wouldn't actually line up just right. So it's usually better to do those rotations first. So this is how I want you to specify the sequence of steps. We're going to say, first of all, how it rotates. But then I want you to draw that intermediate step. So we're going to apply the rule. So here's point A, which is located at 1, 1. Apply point B. Point B is at 1, 3. Point C is at 5, 1. We're going to apply that rule for a 90-degree rotation, which says we will end up with points A prime, B prime, C prime. First we switch the numbers around and then change the sign in front. For B prime, switch the numbers around, change the sign in front. And lastly, switch the numbers around, change the sign in front. Let's plot those points. So A prime is at negative 1, 1. B prime is at negative 3, 1. And C prime is at negative 1, 5. And the reason why I want you to do this is so that we're not just guessing, but we can have a better visual on how it is changing from step to step. Also, you might not have tracing paper, and so you might have to guess a method, and then you check and see if it's ready to then apply the next transformation. And if it doesn't look good, you might need that eraser, clear it out, and guess a different type of rotation or reflection. Try that rule, and then continue onwards. But it looks pretty good, and I think we're ready to now translate. Now again, when we translate, we want to describe how it's translating. So pick a pair of corresponding points. If I pick B prime to B double prime, you can see we want to go left 1 unit and then down 1, 2, 3, 4 units. So describe that. We're going to take each coordinate point on our triangle and move them left 1 and down 4. So don't just say rotate, tell me how it rotates. Don't just say translate, tell me how it translates. And make sure you give me that intermediate step. You have a couple of those on your homework. But first, I want you to try. Now again, there's lots of options here. We're not going to do all of the possibilities. I want you to just do these two. Part A, specify a sequence of transformations that moves figure A to figure D, and then from figure A to figure B. So there's 2 to practice, so we're kind of ignoring C and E right now. What would you have to do to get A over here to D? Specify that in the blank below. And then for part B, how would you get A to B? So you might have to guess and check a little bit, but again, I'm not going to put the answer up here. I want you to think it out. If you come back to class, show me what you have, and I'll take a look at it, and I'll give you feedback at that time.